Welcome to APPA's weekly webinar. My name is Billy Zadig, Manager of Special Projects for APPA. Just a couple of housekeeping items before we get started. The webinar recording will be posted to the APPA webpage later this afternoon. You'll receive a follow-up email in the next couple of days with a link to the webpage where all webinar recordings are housed, as well as a link to our upcoming webinars. We have webinars planned out through December 2021, and many are open for registration. Professional continuing education and AIA CLU credits are being offered for today's program. If you are an AIA professional requiring a certificate, please send an email to me at Billy, B-I-L-L-I-E, @appa.org, along with your AIA membership number, if you have not done so in the past. All attendees are in listen-only mode. Please type your questions in the chat box and they will be answered in the order they are received. If we run out of time and we still have questions, responses will be sent directly to the person asking the question by our presenter. At this time, it's my pleasure to turn this over to Amanda Kirkaby. Amanda, take it away.
Great, thank you, Billy, for that introduction. And I'm going to pass it actually to Rachel Romero and my coworkers for our introductions.
Thank you, Billy and Amanda. Hi, and we so appreciate you all attending here today. We're going to be sharing with you a little bit about the Smart Labs Toolkit and what Smart Labs are. So on the next slide, we'll tell you why we're covering Smart Labs. So laboratories use typically 3 to 4 times more energy than an average office building. And we have seen real case studies that show that there are opportunities in the 20 to 40% range. We've had partners say that laboratories only use 10% of their square footage on their campus, but consume more than half the energy. So there's a lot of opportunity here. So why Smart Labs? On the next page, we will talk about why. A lot of lab owners are looking to increase their safety. Some are looking to implement energy efficiency and sustainability. A lot of people are looking for cost savings or resilience in managing change. With all of these, you can have it all, and we know that these lab spaces are mission critical, but you can look to balance safety and cost savings and energy efficiency all together in one Smart Labs. So when we say Smart Labs, on the next slide, a Smart Lab program enables world-class science through the design and operation of safe and efficient high-performance labs. So in addition to what we just talked about, there is kind of some technical pieces to this. So we're looking at really dynamic ventilation controls. So my colleague Otto will be talking you through that. It's looking at engaging the occupants or the researchers that are in the lab space, which is really important, as well as ongoing operation and maintenance. So when you have a Smart Labs program, you're continually operating the space to high performance standards. And continued stakeholder involvement, whether that be with management or other stakeholders that are in the laboratory. But these are high performance spaces, and often there's a lot of demands on the space. And so we want to help you use those spaces appropriately. So with that, I'm going to turn it over to my colleague, Otto Van Giet, who's going to talk you through the technical pieces of what you might see in a Smart Labs.
So thank you, Rachel, and good morning, everyone. This is Otto speaking, and I'll have in the next several slides, I'll talk about the actual key components. Rachel talked about the Smart Labs program, but implementing that will be the components of primarily the ventilation system. So we'll start with, you'll see this diagram a bunch. But what happens with this diagram is outside air is brought in through the air handling units in the upper right, through a total flow measuring and control device, importantly through a very VAV control box, which I'll talk about later, and then into the room with high ventilation effectiveness diffusers. These are diffusers that are very different than what you'd see in an office space. So we don't want to mix the air. We want to dump the air in and then sweep it through the lab space, which I'll talk about in the next slide, please. So as part of this ventilation control system, we can do what's called demand control ventilation, or setting the ventilation rate based on the occupancy in the space. It'd be very common to have a different occupied versus unoccupied flow, and possibly through looking at the air quality in the space, you know, like total VOCs type thing. So next slide, please. So again, what we want to do is dump the air in. Hypothetically, we have a pollutant in front of the person on the right-hand side. What we want to do is sweep that pollutant away from the person out to the exhaust in the space. That exhaust could be into the fume hoods, which we'll talk about in a little bit later, or out to a general room exhaust, which is what's shown here. So next slide, please. So what we want to do is have high performance exposure control devices. The most common of these is fume hoods. And what we mean by high performance is that they're able to provide good containment, meaning the chemicals stay inside the hood at a lower face velocity. We'll want to verify that performance with a containment test. Next slide. Importantly is the variable air volume controls for the entire building and the entire lab space, and each lab and each exposure control device or exhaust point. And these VAV controls are very sophisticated, and it has to be a system where it measures the exhaust and then correspondingly uses the supply to vary the exhaust and supply airflow based on what's happening in the space. Next slide. So what's also happening in the space, on that previous slide, the arrows were showing what was happening from unoccupied to occupied. We also, finishing the system out, the exhaust goes through the VAV controls into a manifolded exhaust. So one manifolded header for the most of the exhaust there, and then up into the exhaust fans up on the roof. And the exhaust fans control the discharge based on the results of wind tunnel models, which I'll talk about in an upcoming slide. But we can reset those exhaust discharges based on wind speed and direction. Next slide. So here's some other best practices related to lab design. What we want to do is use low pressure drop design. And when you get these slides, you'll see that these underlined areas are all links, and they're links to best practice guides on the International Institute for Sustainable Labs. I2SL has a whole suite of best practice guides that we reference in the toolkits, but that are also on their site, that are things like low pressure drop design. This matters a lot. It's getting the right velocities to minimize the pressure drop. And it matters a lot in labs because they operate 24/7 and move a lot of air. On the previous slide, I also talked about wind responsive variable air volume exhaust systems. And this best practice guide about modeling the exhaust dispersion talks about how to do that. But the most common way is to build a scaled model and test it in a wind tunnel on the campus where you're putting it in. And then based on the results of that, you can figure out how tall the stacks need to be, where the intake needs to be, what the discharge velocity needs to be at different wind speeds and directions. Another important one related to the supply and exhausts to minimize fan energy is optimizing the static pressure based on what's going on, like looking at the exhaust supply VAV valves to set the static to the lowest level that provides adequate control. And obviously, we want efficient fans and controls. And this is just a picture of verifying that, measuring it. And then the next slide. We also talked about fume hoods or exposure control devices. A really important thing is to get the correct number and size of exposure control devices to meet the research needs, but not to exceed the research needs. And importantly, we want to have flexible design so we can add or remove exposure control devices as research changes, and it does constantly change. We also want to use an ASHRAE 110 containment test to verify that the fume hoods are containing as expected. That's why you put them in. We want to set the face velocity, the velocity entering the face of the hood, to the lowest level that provides that containment. There is a best practice guide on commissioning fume hoods that you'll want to reference. We talked about low flow fume hoods. And then importantly, what not to do is don't use canopy hoods. That's a hood that sits up high in the face and provides no containment, so it's an obsolete design. And next slide. Some other things related to energy efficiency is lighting and plug loads. Lighting nowadays is all LED, or should be all LED, and it should be based on occupancy. So occupancy controls, those same occupancy controls can be used to determine whether the space is occupied and reset the ventilation, the ventilation rate based on that occupancy also to the unoccupied rate. Some types of labs have what's called ultra low freezers. And these can be, there's a picture of them on the right. These can be high energy use. The energy use varies dramatically depending on the model you pick. So you want to pick the most efficient possible. And then what you set them at, what you set to operate them at, makes a big difference in the energy use. So they're often called -80 Celsius freezers. Really, they're ultra lows, and what you set them at often can be like -70. So there's many best practice guides related to freezers. Some other things are simple things like cleaning the condensers where the heat gets rejected, and sample management. You know, if you don't need the sample anymore, clean it out of your freezer. There is other equipment types that are used in labs. Use Energy Star equipment types where available, and if needed, and if it works for your equipment, do simple things like put outlet timers on to turn them off. And then another, based on your lab type, high energy user and water user can be autoclaves. There's an upcoming best practice guide by a group called My Green Labs that Amanda will talk about a little later, that will talk about this, sort of like the freezers. But these can be very high energy use, and depending on your selection, you can get a much lower energy and water use. Next slide. And then importantly, you want to engage your lab staff, maybe most importantly. And you want to do that with your Smart Lab coordinator. Rachel talked about this briefly, and Amanda will talk some more. But engage your scientific staff for simple things like with fume hoods, as you shut the sash, first it's safer, most importantly, and second, the energy use is dramatically less. You want to use green chemistry where possible, meaning safer chemistry. And that can, if you're using less chemicals and safer chemicals, you can correspondingly reduce the required ventilation rate. You want to do the obvious reduce, reuse, recycle. And again, this organization called My Green Lab has a lot of best practices related to this. Next slide. Thank you. Rachel, we cannot hear you.
Thanks, Otto. That was a great overview. Appreciate that. Okay, so Otto's talked about all these great technical pieces, and I know he just did a brief overview of that, but we want to share where you can find these resources and learn more in depth about this. So we are presenting the Smart Labs Toolkit, and in the toolkit we have step-by-step guidance on how to approach looking at your labs. This is guidance for both existing and new laboratories. So if you already have a lab on your campus, this is a great resource, as well as there's resources for new laboratories. There are training videos to help you understand more about Smart Labs and this process. We link out to a lot of other resources from very capable organizations. And then we provide some tools, and Amanda will share a little bit about some of those tools, but how to calculate and look at the ventilation. So there's tools to help calculate and understand that more. Finally, we have a great number of partner case studies. These case studies show real examples of our partners implementing a lot of these practices. So all these can be found in the Smart Labs Toolkit. On the next slide, we'll show you the process that's in there. So you can access the Smart Labs Toolkit at any time, smartlabs.i2sl.org. This is the process that you'll find on there. So first, we have some introductory material about, again, more about what a Smart Lab is. I'd encourage you to interact with the graphic on the front page, which Amanda will show you here shortly. So first you plan, and then we're going to walk down the path to assess your laboratories, optimize your laboratories, and then manage. And you notice that we have a circle here so that once you have managed, if there's change, you can continue to assess and optimize your laboratories. You'll notice that this is at i2sl.org. I2SL is the International Institute for Sustainable Labs. I'd encourage you to check out their website as well, but this was in partnership with them. So we're going to talk a little bit more in depth on this process. On the next slide, we're going to go into plan. So in planning, this is where you're going to look to build a Smart Labs team. Our most successful partners when implementing a Smart Labs program puts together a team. And the graphic on the right shows you a little bit of what that team may look like. Successful teams have a champion, maybe a Smart Labs coordinator. Then from there, you want to prioritize efforts. This looks at gathering data and benchmarking your labs and understanding where they're performing right now. And from there, we'd encourage you to develop a Smart Labs roadmap. This roadmap or document will, we have provided a template for your team to fill out and name some of the processes and procedures you're going to take to implement Smart Labs. From there, we're going to go on to assess. And in the assess phase, you're going to perform a laboratory ventilation risk assessment. This is right up top because ventilation is what drives laboratories. As Otto just spoke about, it's a big part of it. And Amanda will show you some of those resources that we have in the toolkit. From there, you're going to identify improvement measures. What changes are you going to make, and develop a scope of work to implement those improvement measures. So on the next slide, we're going to talk about optimize. In the optimized phase, you're going to be identifying funding on the next slide, and you're going to be implementing those improvement measures. And these improvement measures may be simple retuning, maybe correcting diffusers, small adjustments, to all the way to major renovations or retrofit. Once you've implemented those improvement measures, you can develop a building management plan. So how are you going to continue to operate this and optimize it in this smart lab kind of way? So then once you have optimized your lab, on the next slide, we're going to talk about manage. And all of this is outlined in the toolkit, but just wanted to give you a high level review. So in order to manage a smart lab, you're going to do ongoing benchmarking and analytics, and you're going to manage change. So a scientist comes in and says, we're going to need to use this chemical now. So you're going to go back and say, well, this is how the ventilation needs to be, and how do you manage that change? So we have some processes and information to help with that. And then finally, you've done all this amazing work. You can develop performance reports. So this is how the lab is performing. This is how much energy we've saved. This is how much safer our labs are. And really reporting that out is a key part of the program. So from there, we do have one more page in the toolkit, which I'd encourage you to check out on the next slide, which is working with scientists. We do kind of put this separately, but there is a lot of great resources here. Otto mentioned My Green Lab, but they have developed an ambassador program and this is really for the scientists and the researchers. So they can get certified and be a leader, and there's a great program to do that. Their green chemistry that Otto was talking about, waste management, and then equipment specific practices. So information on autoclaves, fume hoods, and more equipment that you might find in a laboratory. Part of this is sustainable procurement. So what options do the scientists have when they are getting their supplies? And then there's a piece on, if you've done a lot of this work, how do you write that into your research grants to make that more attractive? So there are resources for that. So with that, on the next slide, we've gone through the plan, assess, optimize, and manage. So I'm going to turn it over to my colleague Amanda to present the Smart Labs Toolkit live demo. Amanda?
Great, thank you, Rachel. And yeah, with that, we'll take a look at this link at smartlabs.i2sl.org. Wait for it to load here. And when you first come to the toolkit, we'll give a brief overview of all the tools Rachel and Otto were talking about earlier in this presentation. But when you first get to the toolkit, you'll notice a 3D model of a laboratory. And as you scroll through here, you can click on components, and this gives a little description of key components of a smart lab, exposure control devices, what you should be looking for, and where they should be in your laboratory. So that probably catches your eye first, and then we'll give a brief overview of kind of how the toolkit is organized. So we have an introduction page, as Rachel mentioned. This goes into more details on how or why smart labs and components of that in there. And then there's a page for each of the 4 phases of that smart labs process that Rachel outlined, with guidance in each of those, and I'll dive into those in a little bit. Down below, we have a page specifically dedicated. There's some architects and engineers on the call or on the webinar today. So this is for any new projects you are incorporating into your organizations, and dedicates the Smart Labs process to new construction. There's also a page completely dedicated to working with scientists, as Rachel mentioned, with that My Green Lab ambassador program, training videos, and ways to engage your researchers for a successful Smart Labs program. And finally, there's a resources page that captures all the links and tools linked throughout the toolkit in one place. So if you're looking for something in particular, we'll take a look at that at the end of this tour here. But before we get there, we're going to take a look first at the introduction page. So this goes into kind of why, a further description of why Smart Labs Rachel touched on, brings together sustainability, efficiency, cost savings, all these important, and safety really is the primary focus of it. So this goes into what it is and has some videos down below here to engage management and kind of share with folks that might also be interested in implementing smart labs. And then we won't go too much into detail here, but there's more on being a smart labs champion. As Rachel mentioned, it really takes one person to kind of pull all the pieces together and get the right people involved, which we'll go into more on this plan page. So each of the phases of that smart lab process have their own dedicated page. And on the right here, it lists the key steps or kind of deliverables in that phase. And then there's a final deliverable for each phase that helps you wrap up all those tasks and go into the next part of the process. There's also videos to kind of orient you and talk about more what important aspects of implementing smart labs, how to build a team, all that components. Guidance on building a team, as Rachel mentioned. And then on the right here, we also include highlight boxes that link to success stories, case studies from successful partners, and other resources that might be helpful in going through this smart labs process. And then at the very bottom, or actually before, well, at the very bottom, we have a box that outlines and includes templates. So for plan, the final deliverable of that phase is the Smart Labs roadmap to guide the team through the rest of the Smart Labs process. And so include a template for you to download and cater to your specific needs there. And also, I wanted to mention and point out other tools that are included through this. So in developing that plan and Smart Labs roadmap, it's an important part to benchmark, and so we link to the laboratory benchmarking tool, which is also in I2SL tool, helped with the Berkeley lab over in California. You can go in here and include your data from your laboratory and see where you stand compared to other similar labs, and you can go through, and this is all based on people who have entered their data. And so it's a good way to see where you stand and see where you might be able to improve with their new actionable insights. So that's a great planning tool. Back to our planning phase, we'll take a look at the next phase, assess, which really is after you plan. As Rachel mentioned, you go into a deep dive assessment of your first laboratory facility that you prioritized in that plan phase. And this page really has the meat and potatoes of the Smart Labs process, which is the laboratory ventilation risk assessment, really taking a deep dive into understanding what lab ventilation looks like, and going into that lab ventilation risk assessment process. So there's videos on understanding improving lab airflow with smart labs, as well as a few kind of case studies over on the right here, and gathering data, how to go through that process. There's also a few tools that I want to point you to there a little further down, so I'll save your eyes and jump straight to those. But the air change rate calculator and the LVRA tool. I'll wait for my screen to catch up here. But we include a user guide. So this process is where you go in and you assess the risk of the hazards in the research space due to those research activities. So it goes into deep dive, and I'll take a look into what those tools actually look like. So when you download that tool, it's an Excel-based tool, so you can go in and save these files for later use and alter them to your needs. On the first page, there's an instructions just going through kind of how the process is laid out, and we include this user guide. So we encourage you to read that before diving into the nitty-gritty details of the assessment. But we also include, so this process really goes into how to characterize that risk and assign a risk control level or a risk control band to each lab space and each exposure control device. So this outlines the criteria for those hazards. So it goes into what type of chemical it may be that is being used in that research space, how much of it, the quantity, generation potential, how it's being generated, as well as other things such as the dynamics of the space. If it's a quick turnover lab, you have a lot of research activities rolling through, or if it's dedicated to one consistent researcher. Even housekeeping, if people are keeping their lab stations clean, keeping their fume hoods and other exposure control devices clean and free of, not using them for storage, which is a highly discouraged activity. There's storage cabinets for that. And then all those characteristics get weighted and scored into calculating this risk control or risk score for those exposure control devices. And there's a similar criteria characteristics for the lab environment itself. So this is outlined on this page. And then, so that gives you a little bit of the background of what goes into this LVRA or lab ventilation risk assessment. And so this tool helps guide you through, so it includes steps of how you enter information in here, what kinds of information, how you document those characteristics that I just mentioned. So lab space survey information, you would go into your lab, write down all these characteristics, and then start going through and documenting what kinds of fume hoods, what kinds of other exposure, if you have biosafety cabinets or snorkels, you can click in and document them all here. And then you can go through and document what types of hazards each of those exposure control devices are containing. So you can go chemical, there's biological, radio, all sorts of hazards, and an option to write in if this doesn't capture exactly what that hazard may be. So after putting in all these characteristics, you can then use those criteria outlined on these tabs to assign a criteria rating or score to each of those. And these are from a 0, meaning water, no hazard at all, to 4, like the most toxic thing you don't want to deal with at all and without protective equipment. And it lays it out on that scale, and then all these it automatically populates. So if we had a low hazard item, we'd go through and fill out these scores for each of those, and then it would automatically calculate what that risk control band for that exposure device is. You go through, do that for each of your fume hoods in the space, and then also for the broader lab environment itself on a different tab here, a similar process. We won't need to go into that there. And then from those risk control bands and risk levels for that lab space and the exposure control devices, we have another tool that you can input those values and calculate what the air change rate should be for that specific lab space based on those risk levels and the size of the space. And so that you can input in here. And this is an infographic, also walks you through each of these steps and stages and how to input values, as well as including how these values are calculated. So where they're based, what standards they're based on, and how they ultimately calculate the final occupied and unoccupied air change rates. And so that's a deep dive into the weeds a little bit. We'll head back to the toolkit here and go back into the overview. So back in the assess, we dove into our deep dive of the lab ventilation risk assessment. There's also some energy assessment and water assessment guidance, so you can look into each of your components, HVAC, lighting, plug loads, and there's links here to find more about those, as well as water assessment. Another important aspect of laboratories is mitigating water usage, so there's guidance on that. And And further down below, resilience assessment. This is especially becoming more of a hot topic these days, and so we include guidance on that, as well as a direction to a few tools to help you, including technical resilience navigator and some case studies here for navigating how to assess the vulnerability of your organization and incorporate strategies for mitigating any downed operations, especially important now, and people are looking more into that distributed generation and microgrids even. And then at the end, again, we have a deliverable, which is the scope of work for lab upgrades. So you gather those all up in all those improvement measures that you identified through that assessment process and can draft them up into a scope of work, which can then be used in the optimize phase. So clicking to the next page here, this page really goes into how to fund these improvement measures. So there's project funding, resources, and more details on those here, as well as we have the HVAC resource map, which is included in this improvement measures of how to implement them. And there's kind of 3 stages of measures: low, medium, and high efforts. We recommend starting with low efforts to get those easy wins and start showing that your the Smart Labs program is getting the savings that you want it to. And also on this page is the HVAC resource map that I just mentioned and Rachel mentioned earlier in the optimize phase. And this is an interactive tool, so you can go through, and if you want to learn more about lab ventilation risk assessment, you can click through those components, and it gives you specific guidance on strategies for achieving energy efficiency and that laboratory ventilation effectiveness for each of the components of the HVAC system. So another tool to dive more in detail. Back to the toolkit again, manage is also important. I won't spend too much detail on that. Just take a quick look at the new construction page. It includes resources for design build, as well as some case studies from successful LEED and other low energy laboratories and design guides for energy efficient research laboratories. So more resources for new construction in there. The Working with Scientists page, as Rachel mentioned, has this Green Lab Ambassador program. So how to engage researchers and scientists early on and get them educate them on green science practices. And so there's some training videos on that. These goes into who should participate, what the components are, as well as these training videos that are included in that program. Scroll through these real quick. Lots of different topics included in there, and they also have quizzes and webinars to help describe that more. We'll go back to the top here. Oops. And so as Rachel mentioned earlier, we have more on that ambassador program, equipment specific practices, how to encourage researchers to shut their fume hood sashes, and an important part of a smart lab is having intelligent and informed users. So those resources are included there. And to wrap it up, I'll take it to our resources page, where we include a list of all our case studies from the Smart Labs Accelerator and other partners that have successfully implemented Smart Labs and have come up with creative ideas to address different issues, from a lab ventilation management program coordinator to driving energy savings through occupant engagement. So I encourage you to go look at those on this page. There's also that was a lot of information and a lot to wade through for sure. But on this page as well, we include links to all the attachments and tools linked throughout. So including those best practice guides that Otto mentioned earlier as key elements of the Smart Lab. So we include best practice guides, all the tools linked throughout, and they're organized by the phase that they fall in that Smart Labs process. And so I encourage you to look at those resources there. And with that, I'll hand it back over to Rachel and encourage you. There's a lot of tools there, a lot more than we can cover in this webinar. So I encourage you to go through and look at all those tools and worksheets.
Great, thank you, Amanda, and thank you, Otto. We do have a few questions. So the first question, are the spreadsheets available to participants? And everything that we've shown here today is available at this link, and you can go through. Amanda showed some resources where it's all together, but you can, it's also associated with the content. So all of this is available right now at that smartlabs.i2sl.org. Let's see here. We did get a question about, instead of CO2, could you use vacancy sensors at entry to the lab instead? We do have a partner case study on occupancy sensors, so I'd encourage you to check out those occupancy sensor, case studies that Amanda shared as well. All right. Other questions? We'd love to take more or hear your chat. If you want to chat us a comment. I'm going to ask one of our presenters a question, kind of cold question. Otto, can you tell us about an organization that has really implemented Smart Labs well?
Sure, that is a cold question, but I will take it. And kind of the flagship and the inspiration for this whole Smart Labs program is the University of California, Irvine, or UCI. They historically, this is now 15 years ago, Rachel mentioned that often labs dominate the energy use on their campus, on a campus. That's what they found. And some more of the history, the whole University of California system, including UCI, has very aggressive carbon reduction goals, as do many universities, maybe most. So finding that, they took all these practice guides that were already available from UCI. Awesome, what a team. So here it is on the site, and came up really with the Smart Labs program. So they took all this and then brought it a lot further. And the result was that they reduced the energy use on their campus and on their lab buildings especially by 50% or more, often 60%. And then amazingly at the same time improved the safety. So they really kind of brought this process to bear, and that was the inspiration of this whole process. Importantly, they do annual free Smart Labs training, and that'll be coming up in March. So you can do a search for that. Some of the previous trainings are listed here also, and this image is an image from UCI. And this, again, was the inspiration of the Better Building Smart Lab Accelerator, where they were one of the 17 partners that were part of that accelerator. Does that sound good, Rachel?
Yes, Thank you. And now that we've had time to discuss that, we had some great questions come in. Otto, you recommended against using canopy hoods. What is the best way to integrate low demand activities like soldering stations or 3D printers in a lab?
Great question. And the best way is local exhaust. So you can put a snorkel or a high-tech version of a snorkel right by the soldering station. Could be a very small capture hood. So get the exhaust as close to the process as possible. So we always want to contain the process and not let it get in. But a canopy doesn't do that, and it ends up also drawing a whole lot of air, and often draws it right by the user. So it's not an effective approach.
Great, thank you, Otto. Okay. More questions for you. Don't go anywhere, Otto. Is there any information for air compressors or vacuum systems for science labs?
There isn't. That's the toolkit's more focused on ventilation and green chemistry and all those kinds of things. That's not saying that air compressors or vacuum pumps are not important, and they can be major energy users, but there's other resources available if you do some searches. UE has an industrial program, for example, that addresses air compressors. So pay attention to those, but that's not the focus Smart Labs process.
Great. Thank you, Otto. So the next question is, how does a system like Aircuity play into this?
Yeah, excellent. I'll take that one too. On my slides, I talked about demand-based ventilation. And the first and easiest of those is occupancy sensors, and then setting the ventilation to an unoccupied mode based on the ventilation risk assessment that Amanda described. If you want to take that a step further, you can actually do a chemical sensing system. That's what this Aircuity is. And what it does is it draws air from the lab space, analyzes it, and looks things like total VOCs, volatile organic carbons, and can reset the ventilation rate up if some of those are detected beyond a certain limit. It's a great system. UCI is one of the big proponents of it. There is a best practice guide on the I2SL website related to it. So it's something to consider. It depends on your lab type and what you're doing in your lab, whether it makes sense for you or not. But it's certainly a state-of-the-art system that works very well.
Yeah, and then the question after that is, how can we incorporate this system with our toolkit? And I'll go from there. So this is one piece, and a very important piece that can be incorporated. Smart Labs look at the whole picture of your lab. So as ventilation is a big portion of this, Aircuity can help you get there. It's what else do you need with Aircuity to get there? And I really think the UCI example is a great one to include with that, because they do use Aircuity, but they also do work that into their building management system, and they oversee their labs, and they've really fine-tuned their ventilation, and they've taken the next steps hand in hand with that system. Do you want to say anything else on that, Otto?
Oh, that was a great description.
Great. Okay, the next question is, can you use high efficiency diffusers in spaces with biosafety hoods?
Absolutely. Yeah, high ventilation effectiveness is the term I used. Again, it's a diffuser, like a laminar flow diffuser is another related term. but it dumps the dumps the air in at a low velocity, and then you sweep it across the lab space. Biolabs are related. You know, it's a type of lab. High ventilation effectiveness is important in a biological lab also. Biolabs often also have biological safety cabinets that I touched on. So getting the right type and number and size, all those same kinds of things for biosafety cabinets is one of the key opportunities for biological labs.
Great. Thank you, Otto. That was a great answer. So with that, I think we've answered most of the questions. Those were some really great questions at the end there. We appreciate that. Our contact info is here. We work as a team. So if you have additional questions on the toolkit, you can email us and we'd be happy to help you. It was great to hear that some people have some air acuity systems and have looked at this. So I'd encourage you to visit the Smart Lab Toolkit and let us know if you have questions. So with that, I will turn it back over to Billy.
Okay, well, I want to thank Rachel, Otto, and Amanda for today's great session. And I would like to thank our attendees for taking the time to listen to our webinar. As I said before, the certificates will be sent within the next couple of days. And we have, as you'll see on the slides here, we have things coming up for AMPA. And I'd like to thank everyone again for their time. So until next week, when we do another webinar, be safe, stay healthy. Goodbye for now. Bye-bye now.